Hello friends, welcome to WebTechSchool. In today's video, we are going to talk about, given a binary tree, how we can invert that binary tree. So, what is a inversion of a binary tree? So the inversion is if we can swap each node's left child with its right child and the right child with its left child, that will give us back the inversion of that tree. Considering the given example, so what will be the invert of this example tree? So the inversion of this tree would be, so this would be our answer. Okay, let's analyze this. So we have root node as 1. For 1, the left child was 2. Now the left child has been moved to right child. Now for the node 2, the left child was 4. Now 4 has moved to right child and the right child was 5. Now 5 has become the left child. Similarly, for node 3, the left child was 6. Now 6 has become the right child. 7 was the right child. And now the 7 has become the left child. Let's consider another example. Let's say we have this tree 1 and 5. Let's say 7 and 8. Let's say 9. Okay. Now what will be the invert of this binary tree? So the answer should be, this is our root node. Now the right child will become the left child. So 7 becomes the left child. 5 becomes the right child. Now 8 was the right child for 5. So 8 will become the left child. 9 was the left child for node 7. So 9 will become the right child. We need to return back this tree. So this is our problem statement. Okay, so given this tree, we need to return back this tree. Let's write the pseudo code for this problem statement. So the pseudo code will be this. Let's understand this. So what we are doing, if the node value is equal to null, we are not doing anything. We are simply returning. And these three lines are responsible for swapping the left child with the right child and right child with the left child. So we are creating a temporary variable and we are assigning the right child with the left child and left child now with the temporary variable. And the next two lines we are only doing the pre-order traversal, so traversing through all the nodes. Okay, now we will receive the root node 1. So 1 is not equal to null. So what we'll do, so let's say this is our node and we are also having left child and right child. So after the swap happens, so for node 1, the left child will become 3, the right child will become 2. Now we are doing root dot left child, so this is gonna receive 3. Okay, it's again gonna call invert in a recursive way. So the node value will become 3. Node becomes 3. Now once it executes the swap operation, the left child and right child will be swapped. So for node 3, left child will become 7, right child will become 6. Now again it's gonna execute this statement. Let's say we'll say this is as star and this will make it a stick. So it's gonna execute the star. So root dot left is 7. So we are gonna receive 7. Okay, node value is 7. For 7, its left child is null. So here we are gonna receive null. So if it is null, we are gonna return. Now it will execute the root.write statement. So for node 7, root.write is also null. So it's also gonna return. For node 3, now it will execute again root.write. For node 3, root.write is 6. So the node value becomes 6. So we receive 6. For node 7, both are null, so there is no change. For node 6 as well, we have both null values. So it's simply gonna return. Okay. For 3, root.write has already been executed. So it will backtrack to node 1. For node 1, it's gonna execute root.write. For node 1, right child is 2. For node 2, it will swap its left child and right child. So the left child will become 5 and right child will become 4. So here we would have already received 2. Okay, now on this statement, it's gonna receive 2 dot left child, node 2 of the node 2's left child. So node 2's left child is 5. Okay, so for 5, both its left child and right child are null. Okay, so there is nothing to swap. So it's simply gonna return. For node 2, it's gonna execute root.write. So now root.write for node 2 is 4. So it's gonna receive 4. Okay, for 4 also both left child and right child are null. Left child is null, right child is null. So it's not gonna do anything. It's simply gonna return. So for 4, it returned back. For 2, it has already executed the last line, the root.write. So 2 will also return. Now for 1 as well, it has already executed its right child. So 1 will also return. So the final result, what it will give us back is this inverted tree. Now let's run this code in Visual Studio and see if we are getting back the expected output or not. Now we are in Visual Studio and we are working on treeoperation.cs file. Let's create our method. So let's say the method is public static void and we'll say invert binary tree. Okay, so it's gonna receive node root in case the tree is empty, so the root element will be null. So we'll say if root is equal to null, so then we'll simply gonna return. Okay, so we can, instead of void, we can return back the root node as well. So I'll return a tree node and let's fix this. Okay, so if the root is equal to null, then we'll simply return the root value. Okay, so what we'll do a pre-order traversal, and in a pre-order traversal, we'll first do the swap. We'll create a temporary variable node temp equal to, we'll assign it to root dot left child, and now root dot left child, we will do it as root dot right child. Okay, now root dot right child is equal to temp. Now let's traverse through all the nodes. So I'll do invert binary tree, we'll pass root dot left child, and finally invert binary tree root dot right child. Okay, and we will return back the root. Okay, let's fix the spelling. That's all the implementation logic what we need. Let's verify this. So before verifying it, let's go to our example tree. So in the example tree, what we are expecting is this tree. Okay, and for this tree, what will be the its label at a traversal? So if we are doing the label at a traversal, so it will be label by label. Okay, so the value would be 1. This is the first label. On the second label, we have 3, 2. On the third label, we have 7, 6, and 5, and 4. So this is our answer. Okay, so now let's verify in the Visual Studio what we just implemented. In the program.cs, I have already constructed the example tree, what we have been working on. Now let's invert that tree. So the invert class is present in tree operation dot invert binary tree, and we will pass the root element to it, and this is going to give us back a root node. So let's say we'll grab the return value from our method what we have just implemented. Then we will do again just to verify if the root has a inverted tree or not. We will make a label order traversal. So tree traversal dot label order traversal, and label order traversal also takes a root. So label order traversal we have already explained in our previous videos. If you have not watched that video, please go back and watch it. Okay, so now let's run our code and see if it matches our output or not. Okay, let's open the console window. So we got back the first label is 1, the second label is 3, 2, the third label is 7, 6, 5, 4, and let's see what is our expected value. So let's, okay, so if you look at, so we are expecting the first label as 1, the second label as 3, 2, the third label as 7, 6, 5, 4, and we got back exactly the same result. That is it for inverting a binary tree. If you have learned something new today, please give your thumbs up and subscribe to our channel. Thank you for watching.